Hi students, welcome back to physics. We are this week going to take the old equations that we just finished up last week and we are going to turn them into equations that work in 2 dimensions. So 2 dimensions means we're going to be moving both up and down and side to side at the same time. So we are going to start with a horizontal projectile, which means something gets a push outward and then gravity causes it to start falling. It will take the shape of kind of a half parabola. So it'll get a push outward and then it will start to fall, and I'll show you an example of it kind of towards the end. The first thing, a definition of a projectile: any object once in the air can't control its own motion. So it cannot be controlled. So something like a ball, when you throw it in the air, it then falls because of gravity. A marble, an arrow, a bullet, any of those things are examples. So a horizontal projectile is one that which you roll, shoot, throw, anything like that, get it a force throwing in the x direction. So it kind of pushes in the outward direction. And then because gravity starts to affect it, it then starts to pull it down in that half parabola shape. Alright, we are going to look at this in terms of 2 dimensions, the x and the y. We're going to break it apart. The x direction is going to be horizontal, and that will be the push, the velocity in the x direction, horizontal velocity, Vx, is going to be that push in the outward horizontal direction. So somehow you throw something, you push it, you roll it, it gets a velocity pushing in the x direction. We can assume that that horizontal velocity is going to remain constant the entire time for 2 reasons. The first reason is because we neglect air resistance. So we are going to pretend like the air molecules don't slow it down at all. It works well for our labs. Things like marbles just don't, the air molecules don't slow them down very much for the distances that we have them fall. So we get to neglect air resistance. And the other reason, in that x direction, there's not gravity. Gravity works in the y direction, it's not in the x direction, so there's not that gravity force speeding it up or slowing it down. So no gravity in x direction. Alright, so because of this, the horizontal velocity, that outward push, we're going to assume it remains constant the entire time. The y velocity is not going to be the same way. So the velocity as something falls downward, it's going to increase. It's going to get faster as something falls. So we label that Vy, vertical velocity, and that will be the velocity from here down. So as it falls, it picks up speed, except that it also has an x direction with it, so it ends up taking on this half parabola shape. But that y velocity, if you break the 2 dimensions apart, it will be increasing as it falls. There is what we call an initial vertical velocity, VIY, initial vertical velocity, and that is always 0. So just like if I take something and I let it fall in the y direction, it initially has no speed, and then gravity starts speeding it up as it falls down. It's going to be the same with our 2 dimensions. It has no velocity to start, and then as it starts to fall in the downward direction, it will start to speed up. Acceleration, it is going to get a little y behind it, so instead of just being a, it's going to be ay, and that is because gravity is in the y direction only. So we can't have an acceleration any longer in the x direction. X is always constant. It will only work in the y, so we put a little y behind it. The number for gravity is still the same. You need that negative sign, 9.8 meters per second squared. So ay will always be negative 9.8 meters per second squared. The acceleration in the y direction is always due to gravity. For our equations, and we are working in the equation sheet where it says 2-dimensional motion, x and y are no longer interchangeable. So we can't use the same equations for both directions. We have to split them away from each other. So in the horizontal direction, only in the side to side, the x direction, We know that the velocity is constant because we neglect air resistance and there's not gravity in that x direction. So we get to use that little baby equation that we never got to use before, that constant velocity equation. The only difference is we put a little x behind it to show that this only works in the x direction. In the y direction, the velocity is not constant because gravity causes things to get faster as they fall. So we have to use the equation that works for AY. But the nice thing is the initial vertical velocity, VIY, is always equal to 0. So for this week, this chunk of the equation is always going to disappear because 0 times t, doesn't matter what t is, it's all anything times 0 is 0. Don't cross it off on your equation sheet because we'll be using it next week. But for this week, that little chunk is always going to disappear. And then we have delta y is your vertical height, AY is your acceleration due to gravity, and then delta t is time. All right, for example number 1, if you roll a ball horizontally after a 2.1 meter off of a 2.1 tall counter and it lands 1.3 meters away from the base of the counter, what is the Vx? So first thing, and I'm going to show you an example of this towards the end of the lecture, we have little ramps that cause marbles to get a push in the x direction. That push, the velocity in the x direction, is Vx. In this case, that is what it's asking us to solve for, so that is our unknown. The only equation, if you look at your 2, the only equation with Vx in it is that one right there. So that is going to have to be the equation that we use to solve for Vx. In order to do that, we have to go through our list of givens. What do we know in order to start? So I'm going to start by just labeling my sketch and then working through my givens. If you roll a ball horizontally off a 2.1 meter tall counter, so that means right here is 2.1 meters. That is up and down. It's a height, so it's delta y. So delta y is 2.1 meters. Technically, it's a negative 2.1. That negative sign is just in there to cancel so you can take a square root. If you forget it, it's okay. But because it's falling downward, it's a negative 2.1 when we plug it into our equations. It lands 1.3 meters away. That goes right here on my sketch. 1.3 meters, that's going to be the distance in the x direction. So delta x is 1.3. There are also 2 givens that are always automatic for these problems. 1, the VIY, the initial vertical velocity, has to equal 0, so you get to use that one automatically. And in the y direction, the acceleration is only due to gravity. So AY is negative 9.8. We now have enough variables to start looking through our equations. Okay, I want to solve for Vx, which means I have to have delta x and I have to have delta t. Delta x is 1.3. That's awesome. The problem is, nowhere in that problem does it give me delta t. So I'm going to have to work backwards. I am going to have to use one equation to solve for t, this one right here. And then once I have t with my delta x, I can use it to solve for Vx. So step 1, I'm going to need to solve for t. I am going to use the equation in the y direction because I have enough information. I have delta y, I have ay, I can use that to solve for t. So here's my equation, delta y equals VIY delta t plus 1/2 ay delta t squared. The VIY is always equal to 0 for these problems, so this chunk automatically cancels out. From there, I am ready to plug in numbers. Delta y is 2.1. Technically, it's a negative 2.1 because it's falling downward, and that's just to cancel out a negative later. That is equal to 1/2 times negative 9.8 times t squared. These 2 numbers, you can multiply them together first to get negative 4.9, or you can divide them under individually. When you do that, you find, and then Last step, you have to square root, because that will be equal to t squared, not t. Once you do the math on that, dividing over square rooting, you should get t is equal to 0.655 seconds. And you can certainly round differently than I do, but we're just kind of getting ourselves a t. I went to 3 decimals because that's kind of, calculator-wise, that's kind of where I had saw a nice break for that. All right, moving on from here. I am now ready. I have a t and I have a delta x. I am ready to solve for vx. So step 2 is going to be to solve vx using vx equals delta x over delta t. My delta x was 1.3. My time that I just solved for was 0.655. When I divide those two, I get just under 2. I got like 1.98, and it's a velocity in the x direction, so my units are meters per second. All right, so just to recap, something's getting a push in the x direction, giving it a horizontal velocity, and then gravity is causing it to fall at the same time, which is giving it this little half parabola shape. If we know the height, we can solve for t, and then once we know the t with the delta x, we are able to calculate vx. If you did not do any of those calculations with me at that point, pause the video now, type those into your calculator, and just make sure you get from there to there and there to there. All right, moving on to our second example. We have, this is my hill. Here's my cannonball that's going to be coming out of there. It is going to come down like that. It is shot off a hill that is 18.5 meters high. So 18.5 meters is the height of it. That's going to be my delta y. Delta y equals 18.5 meters. I'm going to put a negative sign in there in case I need it, because it's going to fall downward, in case I need it to cancel out to take a square root later. I'm just going to get it in there to start with. Once again, if you forget it, you'll just get to a point where you have to take a square root, and you'll just have to make it positive instead. How far away from the base of the hill will the cannonball land? So the base of the hill is right here. That is delta x. So I am solving my unknown. I'm solving for delta x. If it is shot horizontally at 95 meters per second, that's my vx. That's the push outward is 95 meters per second. So I'm just going to write that as one of my givens as well. My vx is 95 meters per second. I'm looking for delta x. Once again, in the x direction, that is the only equation. Vx equals delta x over delta t. It is the only equation that's going to work. But in order to solve for delta x, I need vx, which I have, but I also need delta t. So we're going to have to do kind of the same process, and we're going to solve for t using the height, and from there, we're going to be able to solve for delta x. I have 2 more variables that are always given for these problems. The VIY is always equal to 0. That initial velocity in the y direction always equal to 0. And the acceleration, AY, in the y direction is always our negative 9.8 meters per second squared. Switching colors. Once again, step 1, I need to find the t. I don't have that yet, so I can't solve for that without it. I can use my y equation. Delta y equals VIY delta t plus 1/2 AY delta t squared. The VIY is equal to 0, which means that first chunk is going to cancel out. From here, delta y, negative 18.5, is equal to 1/2 times negative 9.8 times t squared. I need to divide these over. You can multiply them first. 1/2 times negative 9.8 is negative 4.9, and then divide them over, or you can just divide them one at a time. And that will give you a decimal, but that's not your t, that will be your t squared. So then your last step will be finding the square root of each number, and then you should get delta t equals 1 I got 943 seconds. I just leave it in my calculator so I don't have to worry about rounding or anything. I just leave it in there for me to do the next set of math. So if you get slightly different answers, different rounding, that's totally fine. From here, check, take a pause, check your math, make sure when you divide these over and then square root that you get that for your t. My last step, I need to solve for delta x. I needed a different color, sorry. And I'm going to have to use Vx equals delta x over delta t in order to do that. That's the only equation in the x direction. My Vx was 95. My delta x over delta t. To get x, this has to multiply off the bottom. I got to cross multiply and divide. This multiplies to the other side. And so if I take 95 times 1.943, I end up with a delta x of 184.6. You may have it closer to 184 if you dropped off this number. You might have it closer to 185 if you added an extra number. So it just depends on how you rounded your time. We'll give you a slightly different answer for delta x. Somewhere around 184 or 185 is what we're looking for. All right, so these are horizontal projectiles, something that gets a push in the x direction and then starts working its way down. I'm going to quickly show you how to set up the marble lab. I ended up putting numbers in, and then I'm going to just show it to you right here. So I'm going to pause the video and then kind of go over, move it to a different spot.